Hi, everybody. Welcome to KubeCon. Very excited to be here in what is my favorite event of the week, Platform Engineering Day. Thanks, everybody, for being part of this. Exciting to be part of this thriving and growing community. So today, we're going to be talking about why platform engineering is the key. It's a key lever in sustainable cloud infrastructure. My name is Ramiro Berrelleza. I am the founder, CEO at Okteto. We're a startup that builds platforms very focused on automating development workflows. Big fan of dev tools, platform engineering, open source, and food. So if you want to connect, I'm Berrelleza in most places. We will put in these slides on the Platform Engineering Day page and also on my personal page. And with me, I have...
Hi, everyone. This is Nancy. I am super excited. This is my first talk with Ramiro. I work at Agno as an engineer. I am a CNCF ambassador. Any fellow CNCF ambassadors? Whoa. OK. I also founded Women in Cloud Native community. We have a Women in Cloud Native gathering tomorrow, so please do join. And I also led CNCF Sustainability Week 2024, which was basically an event where all the people who were super excited about the topic of sustainability in tech, they organized events in their respective countries. I was also Tag Environment Sustainability Co-Chair, which is now restructured. So we're going to talk more about this in talk, but if you're interested to contribute, I'm going to tell you more in the end. And if you want to know more about me, you can scan the QR code. That's my website. Yeah, so cool. So this is an open-ended question for the audience. What percentage of global carbon emissions is the IT sector responsible for? Any guesses? Any random guess? 70%. Did you say 70? 70. OK, that's a big number. Anyone else? But we're, yeah. 10%? 2%. Oh. Yeah, that's right. It's 2% global carbon emissions. But moving to the next slide, as one of the person said 70%, it's going to increase to 12% by 2040. It's a huge number. 70 is huge, but 12% is also very, very huge. Like, we are contributing a lot to the environment. So as software engineers, we are definitely responsible for this.
And that's what I wanted to talk about today. You know, we normally give talks kind of be more technical, but as I was chatting with Nancy, we both feel like sustainability is something that is very important and is something that we, as platform engineers, are especially well-suited to be a part of. You know, maybe not fix it all on our own, maybe, but we are well-suited to start thinking and attacking this problem. No? As Nancy said, and as the audience guessed, 2% of emissions is what the IT sector is generating today. That is a lot, and it's going to keep growing. Of course, because computers are useful, the cloud is useful, and now we have this new player. Maybe you've heard about this thing called AI, maybe not. But it's something that is growing. And, you know, it's here to stay. It is very useful. I know there's a boom. I live in San Francisco. There is a boom and bust cycle around this. But it is something useful. It's going to be here to stay. And it's a very hungry player in the world of power consumption. So hungry, though, that the other day I was reading this interview by Satya Nadella, the CEO of Microsoft, that he was talking about how they actually have GPUs now sitting on crates on their data centers because they just don't have enough power for them. They need to build more data centers. They need to get more power. In the US, we're talking about nuclear as a way to kind of solve this. And yeah, that's not the way forward, no? Because at the same time that we have all these new energetic needs, communities are starting to push back very strongly on building more power-generating facilities, whether it's because, you know, they're taking water from communities, because of pollution, fear of nuclear. And, you know, you might be on one side of this debate or the other, not here to decide if it's true or not, but it is real, and we have to balance all these needs of industry, of communities, of users. And, you know, unbounded compute growth is just unsustainable. You know, even if we put data centers in space, which there is in San Francisco trying to do this, it's still unsustainable. We need to do something about it. Just like, you know, and we've done this before, no? When cars became a thing, when planes became a thing, when computers became a thing, it's always this cycle of first we find use, we go crazy, and then we have to rein it back and be better about it. And that's where today I want to talk about the economic opportunity that we have in marrying sustainability with company goals, with capitalism. Cloud bills are now board-level issues. If you follow some of the big public companies, you see how they're mentioning their cloud spend on their investor reports, on the calls they do. Private companies, they're discussing with their investors. Like, cloud bill is becoming a bigger and bigger player. There's a whole new discipline of FinOps that some of you might know of. There is a foundation, there's companies because of this. And why I'm excited about this is because I believe that sustainability and cost optimization can be two sides of the same coin. We can use this incentive of saving money, which is something that every company in the world, they want to save money, they want to increase profits, they want to lower margins. No one will ever tell you, no, I don't want to lower margins. We can use that as a way to build a better incentive model where we can save money for organizations, we can save energy, and we can save not really the planet, we can save ourselves and have a comfortable place to live. So I think there's a big opportunity right now to move from being green because it's morally correct to being green because it helps companies make money. And we've done this before. This is one of my favorite examples when it comes to sustainability, which is what happened with LED lights. I'm old enough to remember incandescent bulbs. They were expensive. My mom would shout at me every time I left the light on because it was so expensive. You had to always go around, turning the lights off all around the house. And at some point, the industry, the government, kind of got together and started pushing for LED light bulbs. And it worked. Most light bulbs these days are LED. Why? Because they're cheaper. They last a long time unless they're like defective. It was good for the industry because they got to sell you in a whole new like range of novelty for something that was a very stagnant market of light bulbs. And it was overall good for all of us because it did lower emissions. And I think that's something we can learn from and apply, not the same, but similar to how we think about cloud infrastructure. And that's where we can all kind of come in. Because we control the runtime of modern software. Any company has a mature platform engineering team, which I hope everybody in this room either works for one or you will make your company get there. We are in the center with this hub where a lot of technology's choices are happening, right? We get to set defaults. We get to provide golden paths. We get to define what efficiency means. My company is very focused on development efficiency. Others are more focused on infrastructure efficiency. But at the end of the day, we're making all these choices to help developers do their work. And through that, we have an immense influence in these choices that we're making at team, org, and industry level. I mean, we're all here because we care about platform engineering, because we all believe that this central model makes a lot more sense than letting every developer do their own thing. The same happens with power efficiency. Because at the end of the day, every decision we make has an impact on this. Whether we have multi-tenancy or single cluster, whether we are autoscaling our clusters or not, are we moving to ARM, are we giving every developer a full VM or a bunch of pods, all of this reflects consumption, cloud bill, energy consumption. No? Whether you're like cloud, probably you care less about energy consumption. If you're like bare metal in your own data centers, this becomes a bigger issue. But it's all over the place. It's one of these choices that the more you learn about, the more you realize it's there. And that's why I see platform engineering as this lever for systemic sustainability. This is not about all of us feeling good about being green and doing one thing. No, it's about building this in a systematic way, in an automated way around platforms and around all of our organizations. And this is an example of something that one of our customers at Okteto drove, which was super interesting, and what kind of gave me the idea for this talk, as I was chatting with Nancy about what to talk about, was there's a financial services company in Canada. We don't have rights to their logo or name, but it's a big one. I'm sure you know of them. And last year, they were like, hey, the platform team chose to move from AMD workloads to ARM. They're running on EKS. And it was very surprising that the platform team was very surprised with how easy it was for them to port their application or validate that their application was a Django app, high global scale databases. I was able to move from AMD workloads to ARM and to their developers. And they did this through the platform. They didn't go around asking every product team to do this. It was like, hey, we have these sandboxes. We have this platform now has a button, deploy on ARM, deploy on MAD. They did the initial testing. And after 6 months, it's not a one-day thing. It took a while. But after 6, 8 months, they saw a 40% lower cloud bill. Again, incentives. Stakeholders were happy. They're spending less in cloud. Developers were happy. They didn't have to do the work. They got faster machines, better. Their customers were happy, better infrastructure. And people who created the world was happier because our workloads are lesser. They're consuming less energy. They tend to require less energy. And this gave them high performance, lower energy, low cost. And this was driven entirely through the platform team. The team building Apache Doris just released a white paper like 3 days ago. I didn't have time to put it on the deck about the same thing. They saw I think it was a 70% increase in performance by moving Apache Doris workloads from AMD to ARM. Just Google it, Google Apache Doris and ARM. It'll come up. Super interesting findings. And we can do this today, right? Like this is where we're good at. We can auto-scale based on real usage, stop guessing, implement ephemeral environments so that you can just throw them away when you're idle, bring them back on, on the Monday morning when your developers are back. Experiment with ARM as a way to save money, increase performance. Schedule your workloads based on time, benefit from time zones. If you're building physical data centers, you can benefit from access to cheaper energy in different parts of the world. There's a reason why there's so many cloud regions in Virginia, in the US, and in Colorado, and in Oregon, because there is cheaper power there. And now you can start using a lot of the new observability tools to start to track this. And that's very important. Again, this is not a do or die one day and you're done. This is about building this in a way that is systemic, where we can leverage what we've been doing already. And just the same way that 2 years ago, cloud, or maybe more, cloud builds became a thing, and FinOps, and you're tracking, and now we have open source projects that will tell you this PR is adding this much to your monthly cloud costs. We can do the same thing with energy.
Awesome. Cool. So, yeah, I just wanted to check this. Anyways, so really loved it, Ramiro, and 40% savings is huge. That's amazing. But as we move from platform teams, so I'm just assuming most of the people here are from platform teams. Can you okay, I see bunch, I see a lot of hands. So yeah, Ramiro, building platform tool. So I just have a question, how many of you feel that AI is a bit unavoidable, from now onwards? We know that AI is there. I see a bunch of hands. Okay, cool. So this talk was, when I was preparing with Ramiro, this talk was more about initiating this conversation because we know that AI is becoming unavoidable. Almost all the organizations, they are either experimenting, they want to build their own AI agents. Somewhere they have AI workloads which is running in their stack. So this is something which is unavoidable. And again, this falls on platform engineering team. So the efficiency falls back again on platform teams. And this is something which I believe that platform teams will now be controlling the runtime of AI modern software. So AI workloads scale faster than anything before. In fact, there was this one study which has shown that training one large model is equal to, it emits the CO2, the carbon emissions of 5 cars' lifetime, which is huge number. And almost all the enterprises are running inferences that burns a lot of GPU. And then we know that the GPUs are scarce, they are expensive. So yes, we are going to initiate the discussion in the AI domain because most of you feel that it's unavoidable. So agentic and AI efficiency levers. AI workloads magnify everything, especially the power draw. They consume a lot of compute. They consume more GPUs, memory, and they require more cooling. And we all know that GPUs are expensive, they are scarce, and they're going to become obsolete very, very fast. So how do platform teams manage this? When and how the GPU should be used? Just like initially, we have been tackling with CPUs, CPU autoscaling, you have been right-sizing the clusters. Similarly, we have to see that what can we do when it shifts, when the focus shifts to the GPU side of things. Well, allocate just in time. Like, you need to spin the GPUs only when the jobs start. And there are different projects in it. Run AI, Kubernetes, these are different projects which help you do this, allocate just in time. Then shut down the idle sessions. No agent should hold a GPU after its job is done. Then monitor energy per job. So this is one thing which we have been saying a lot even when the tag environment sustainability exists, that the only way to track the cost and the energy consumption is to measure it. So you will have to build the measuring, you will have to build those observability around that, how much is the token usage, how much is the energy usage. So the next one is context engineering meets platform engineering. So context engineering is basically designing how an AI agent sends and receives the information from an LLM. So it controls like what your model knows, remembers, and focus on. So the key question is, what information actually helps you to get the right answer? So if you have like extra tokens, that is equal to wasted compute. And that's how context engineering is important to platform engineering. Basically, context engineering helps developers manage intelligence like infrastructure, control what runs, remove what's not needed. So here I have written some points, like every unnecessary CPU cycle or token in today's context, when we are shifting to AI, is equal to wasted power. Right-size clustering, like we used to right-size the clusters, and now we might have to shift that focus to right-sizing the prompts. Then AI sustainability, cloud sustainability began with right-sizing the clusters, and it will now shift to right-sizing the prompt. So every token the model reads is like a CPU cycle. So it burns power and memory, and that's how we know that why it's important to move into this direction. Platform and AI systems both thrive when designed for minimalism. So here are some points which you can work on. Instrument the tokens, which I mentioned that we need to at least measure to take some actions. So you need to log and visualize the token consumption. What's the agent run in your observability stack? The second one is use task-specific models. You cannot use like just one model. For example, you can't call GPT-4 for every use case. Like every use case has different models which you can use. And then the next one is set context limits. So you can cap the chat or runtime history. For example, 3 to 5 turns. I'm going to show the benchmarking as well later. And cache the static prompts. So you can also cache. You can reuse the agent infrastructure rather than just regenerating all the time. OK, so this is the, how should I play? OK. OK, so this is the benchmarking which I did. So there are 2 agents which are running side by side. So one is like baseline, which has no limit, and the other one is optimized. It just calls like 3 calls. It just called tool calls 3 times. And you can see that there is token savings, and eventually the cost savings, and also the context reduction. So the whole point was basically LLMs reprocess the entire conversation history each time a new message or tool calls are made. So you can, like, by introducing, I did this benchmarking using Agno framework because I'm quite handy with it right now. But you can basically look for different design patterns when you're using different framework to build your agents. You can see that how you can build context-aware design. And that can eventually result in token reduction and the context reduction and eventually the cost reduction. The next one, I did benchmarking for the caching. Let's see if it works. OK, cool. So I did the benchmarking. This highlights the redundant compute during development. So, OK, so as you can see, I did the benchmarking with caching and without caching. And again, we can see like how many tokens are saved. the cost is saved, and the time is saved. So by introducing just one parameter while building your agents, cache response equal to true. So repeated queries are served locally. So this is how, these are the different, so these are one of the few patterns which I observed. And you can basically use these patterns with different frameworks to reduce the tokens. So yeah, this is about the AI.
Now, we do that a lot in our company. As we get deeper into AI, use cache prompting is a very powerful tool. So a lot of open source solutions out there, measuring your context, limiting it, packaging it, it's amazing. So just to close on this, unbounded compute growth is unsustainable. I'm going to get that on a coffee mug. I really like that phrase. But it's true, no? It's key to align financial and environmental incentives. Every compute unit you save maps to power save, maps to lower costs. This works for everybody. We're starting to see more kind of bleeding edge organizations trying to think about power as part of their KPIs in their platform organizations. Highly recommend start looking into this. It's very interesting. And sustainability matters. It's going to be getting involved into all of our dashboards, into the reports. And this to me is going to happen. No? I think we can be accelerators of this. And we can all together go from FinOps to GreenOps to this new idea of sustainable ops. And we can start, not today, enjoy KubeCon, but tomorrow, or I guess next Monday, depending if you're staying for the whole week. We can start doing this. Now, take ARM for a spin. I've been very surprised of how much we get out of it. Start caching your prompts in a lot of these models, and it's just on the Cloud SDK, I think it's just a set true or false. It makes a huge difference, especially if you're reading a platform where we're going to be reusing the same caches, same models, same answers. Track metrics, energy metrics, you can do Prometheus, Grafana, virtualized GPUs, done by 1 GPU per developer. DPUs are depreciating very fast, done by as many as you need, share them as needed, and really educate developers on this. No, it's important for developers to understand that all these actions have resource consequences, but also automate. My entire career, I've been doing this, building systems to automatically delete databases and idle instances because all of us forget all the time. And really push for tag green reviews in your org. Nancy's been doing a lot of the work on this space for a long time, so she's a strong reference of how, why to do this. So really, really check it out.
Okay, yeah, so we are wrapping up. Thank you, everyone. Here are a few resources which you can follow. We have green reviews tooling. That is one of the open source project, you can check out, you can scan the QR code, you will find this repo on GitHub. So basically, you can conduct green reviews on your project before releasing that into production. So you will basically know how much carbon emissions is your project emitting, and there are other metrics as well. Then this is one of my favorite video, Go Green with Kubernetes. So you can scan the QR code, learn more about it. You can also join Tag Environment Working Group Green Review. In short, a lot of words, tag working group, but in short, it's a group with people who are enthusiastic about the green reviews. So you do discussions, you also conduct the green reviews with some of the existing Linux projects, Linux Foundation projects. So you can join that group if you're willing to contribute. And then there is one video which is Green AI in Cloud Native Ecosystems. This was in the last KubeCon. I really loved this talk. So definitely watch this out. And yeah, you can check out the landscape, Cloud Native sustainability landscape, very overwhelming. But yeah, definitely look out for projects if you want to contribute in any of the projects which is related to sustainability or platform engineering, definitely.
Thank you, everybody, for your time. I think we'll be over, but thank you. If you want to chat later, QR codes are there.